Friends, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about one of the most important algorithms in machine learning. It is k-means clustering. Let's start. So first point you need to understand, the most important point is it is an unsupervised machine learning. It is unsupervised. You know, machine learning is classified into three categories: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. You know those aspects. So I'm telling k-means clustering, it's an unsupervised machine learning algorithm. The second point, it's a clustering algorithm. See, clustering means it's grouping of data. It is grouping. It's the second important point. See, clustering is an unsupervised machine learning technique that involves the grouping of data points. See, data that are in the same group should have similar properties or similar features. That's what we do in clustering. K-means clustering. It's a clustering algorithm. So these 2 points, it is fundamental points related to clustering algorithm. Now I am getting into the details of this algorithm. So in the name, it is k-means clustering. So first I am going to talk about what is k. K is the number of clusters you want to identify in your data. So you want to group the data, the given data. Our aim is to group the data into different clusters. The number of clusters is k. The number of clusters, k is the number of clusters or groups. We call it as k. But in the beginning we don't know. So we will take an arbitrary value for k and proceed with that. So what that arbitrary value, there is a specific method is there. That method also I will be explaining towards the end of this video. So there are some specific method. We can't randomly take some value for k. So that we will discuss at the end of this video. So k is the number of clusters in this k-means clustering. K is the number of clusters. So what are all the different steps? Now I am talking about the different steps involved in this process. See, you have different data points. So here you have the data points. Here you have some set of data points. Here you have some other set of data points here, but I have shown it in different color, and it is these two are two different clusters. But in the beginning, actually here we know this is one cluster and this is another cluster, but since it is shown in different colors, if it is not shown in different colors, we don't know. We cannot categorize them into two different set of data. Then what we will do, that's what we are going to discuss, the process of categorizing or grouping this data, how it should be. That's what I am going to discuss. So we have a set of data here. It is a one set here, it is given like this, and one set it's given like this. How we will classify this two? The different steps involved in this process is, the first step, it is select the number of clusters you want to identify in your data. That is, we are arbitrarily taking the value of k. K is equal to, let us assume some random value. Let us assume that we have k is equal to 3. Let us assume that we have 3 clusters. I am taking one more group as well here. So here I have shown with different colors, but it's not the case. You don't know beginning what is the what is the different group, you don't know, but for your understanding I have shown it with different colors. So let us assume that k is equal to 3. There is a specific method is there to start, to begin with. What value of k you will take, I will be explaining this. So we have the first step is, so first we assume that k is equal to 3, and that 3 is the number of clusters. That is the first step. Select the number of clusters you want to identify in your data. This is the, there k is equal to 3. The second step is select 3 distinct data points in this different clusters. So you have 3 clusters. In these clusters, randomly you are selecting 3 distinct data points. Those data points, we call it as the centroid of each cluster. We call it as the centroid. For this cluster you have one centroid. So I am taking this as the centroid of this cluster. You can select one. That's also we are taking arbitrarily. So this is the centroid of this cluster, and you can take this as the centroid of this cluster. You don't know. You are arbitrarily taking 3. That is the center. It's in the centroid means it's the center, but we don't know what exactly is the center. You have taken 3 arbitrary points in these 3 clusters. Even your clusters are arbitrary. You don't know exactly. So that identification is only the process we are going to do now. So you got the centroid. Now the distance from the first point. So you have different data points in this, cluster. So I am taking some more data points here as well. So you have data points like this. You can have data points like this. Okay, so like this. Red you have here as well. Okay, green I am showing it here like this. So I am taking the first data point. The first data point, so the step 2, the step 3, the step 2 is identification of the centroid. Now I am getting into the step 3. What is the step 3? We are taking one data point from this entire data set, and distance from the 3 centroids we are calculating. See the distance from the centroid towards one data point. The data point I have taken is, this is the data point I am taking. This data point I am taking. This is not the centroid. You need to understand, this is a data point. The same process you will repeat. So this is a data point I am taking, and the distance, these 3 are the centroids. These 3 are the centroids. These 3 are the centroids of the 3 clusters. The distance of this data point from these 3 centroids, this is from the first centroid, this is the distance from the second centroid, and this is the distance from the third centroid. You are calculating the distance of this data point from the 3 centroids. The distance you can calculate it by using different formulae: Euclidean distance formula, Manhattan formula, or Minkowski distance formula. These 3 are the commonly used distance formula. If you are using the Euclidean distance formula, this is the formula: root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is the formula. That is, x1 y1 and x2 y2 are the coordinates. Then the distance between these 2 points is x2 minus x1 the whole square plus y2 minus y1 the whole square. This formula we call it as the Euclidean distance formula. Even you have Manhattan formula or Minkowski formula. I have a separate video. I am planning to create a separate video for this distance formula. You can watch it. So this is the Euclidean distance. You can calculate the distance. You understood that even though this data point is coming under the red cluster, it is close to the first cluster. The first cluster, this I am taking it as A. This cluster is this centroid is B, and this centroid is C. Our data point, the distance, you calculated the distance, and you can see the minimum distance. See, the first point is see, the minimum distance is towards A. So the first point we can add to the cluster, this cluster, the centroid is A, that cluster, because it is close to the cluster, the green color. So the data point we have taken, the distance is less towards the centroid A, so you can add that point towards this green cluster. So we will add this point towards the green cluster. So this is part of this green cluster. So now what will happen if the first point is added to the nearest cluster, that is the green cluster, then again for the green cluster we need to update the centroid. So this point also it came, so we will update the centroid by using we calculate the mean. See, if these points you take it as the you can assume like they are numbers, then how we will calculate the midpoint? We will calculate the mean. So again we will calculate the mean of this first cluster, and we will change the centroid from to the next point. We will change it towards from this centroid, we will change it somewhere here. The centroid is updated. That is the fourth step. So what is the fourth? The first point is added to the nearest cluster. That is the fourth point. Sorry, the fourth point is the first point. Sorry, the data point is added to the nearest cluster. Data point is added to the nearest cluster. Here we have added the red data point to the green cluster. What is the step 5? Again we will change the centroid of the green cluster by taking the mean. We will again change. You can assume you assume like just as numbers, then you will calculate the mean, and we will change the centroid. So we will update the centroid, then calculate the mean of each cluster. We updated the centroid. Again we will take the second data point. This process continues. So we updated this. I am taking another data point here. So this is another this black I am taking. This is our next data point. Again I will calculate the distance from the first centroid. Our centroid is now this. It is shifted from this. The distance again from this, the minimum distance is towards the green cluster. Again this point is added to the green cluster, and again the centroid of the green cluster is updated. This process continues. This is the different steps involved in the k-means clustering. I think you understood the different process. Now the one and only thing remaining here is I told the value of k, how we will select the value of k. So here I have taken arbitrarily it as 3. So there is a method known as elbow method, that the value of k is calculated by using a method known as elbow method. So the elbow method, I will tell you, it is known as the elbow method. Elbow method, what it is like, it's a plot between k and the inertia. Inertia means the sum of squared distance of the samples to their closest cluster center. Inertia means it is the sum. See, I told you, for each point you will take the squared distance of the data points from the closest center. So you have different data points. So each data point you calculated the Euclidean distance from the centroid. That distance you will square it. The first data point you calculated the Euclidean distance from the centroid, you square it. For each data point you will calculate the distance from the centroid, then you square it, then you will take the sum. We call it as the sum of the squared distance of the samples from to their closest cluster center. That is SSC, sum of the squared distance from the closest. That we call it as the inertia. It is a graph connecting inertia and K. So what is inertia? Inertia, you have three clusters. One is you have three clusters here. To this data point you will calculate the distance by using the Euclidean distance. You will calculate the distance between the centroid and the first data point. You will get one value. Let us assume that it is 2. Next data point from this centroid you will let us assume that it is 4. You need to square it. 2 square plus 4 square plus to this data point from this centroid you will calculate the distance, that is again 3 square. Like this you will add it. That is the sum of the squares of the Euclidean distance of the data points from the centroid. That we call it as the inertia. And the K here it is 0, here it is 1, 2, 3, 4, 5, 6. When you plot this graph, see, you know, as K increases, the sum of the squared distances will decrease and finally it becomes 0. As K increases, the number of clusters increases, this distance decreases and finally it becomes 0. So the plot will be like this. So it looks like an elbow. So which is the minimum point here? This is the minimum, this is the elbow, this is the minimum point. So we will take, it meets at 3. It is close to 3. So K is equal to 3. This is the method of finding out the value of K. So that is K-means clustering. The practical applications for K-means clustering, if you are asking, it is used for document classification and recommendation systems. This is the most commonly used algorithm, that is K-means clustering. So that's all about K-means clustering. Thanks for watching. Please subscribe my channel.